All right, happy Valentine's Day. I hope you guys are having a fabulous day. I hope you guys continue to have a fabulous day. Today we're going to learn how to get area of subregions. We kind of already know this, but the new concept is we're going to do, we're going to integrate with respect to y instead of x. So let's do what we know already. All right, so here we go. Example 1. Finding area using subregions. It says, find the area of the region R in the first quadrant that is bounded above by y equals square root of x and below by the x-axis and the line y equals x minus 2. So here it is, guys. Here's the region I want. I want you to recognize that there's two different distinct colored regions. That means that they are, the region in gray is just the square root of x from 0 to 2. And the region in blue, the top curve is the square root of x, and the bottom curve is the linear line x minus 2. So I usually like to do a vertical line so I can see what's top and what's bottom, top and bottom. And then on this one, it's just the square root of x. And I guess if you want to count the y equals 0 as a line, so minus 0 if you wanted to. So here we go. How do I find the total area? Area under the curve from 0 to 2 of the square root of x dx plus area under the curve from 2 to 4, and then the top line is the square root of x function, minus the bottom line is the x minus 2, close dx. Cool or not cool? Nothing crazy. If you want to distribute this negative, then this integrand here from 2 to 4 is just integral from 2 to 4 square root of x minus x plus 2 dx. And you can put parentheses on all that if you want to. You don't necessarily have to. All right, let's see how this works, just doing it longhand. So antiderivative of square root of x. Remember that the square root of x is just x to the half. Now, some of you yesterday were confusing antiderivative with derivative. It's not derivative. You're doing antiderivative. So we add 1. X 1/2 plus 1 is 3 over 2, or 3/2. And then we divide by 3/2, which is the same thing as multiplying by. This is the only term that's going from 0 to 2. So I put that in brackets, 0 to 2. Plus, I already know what the antiderivative of square root of x is again. I'm going to write x, or 2/3, x to the 3 over 2. And then I'm looking at this antiderivative here, or this integrand here. The antiderivative of negative x is just x squared over 2. Is anyone lost? And the antiderivative of 2 is 2x. All three of those terms, put them in a bracket like this. And I'm going to evaluate those from 2 to 4. And this is the terminology, or here's the math language that we use. Cool or not cool? Cool. I don't have to worry about the 0 for this lone guy, because 0 to any power is 0. Well, except to the 0, but that's a different scenario. That's indeterminate, so don't even worry about that. So all I got to do is worry about that 2. So 2/3, let's see, 2 to the 3/2. I guess for now I'll leave it like that. Plus, and I'm doing upper minus lower. So let's see, giant parenthesis, 2/3, 4 to the 3/2, and we'll talk about how to do it without a calculator in a little bit, minus 4 squared over 2 plus 2 times 4, close my giant parenthesis, that's this one here, minus another giant parenthesis. I'm plugging in my 2 now, guys. 2/3, 2 to the 3/2, minus 2 squared over 2, plus 2 times 2. And then here's my bracket. Yeah, I'm just doing the lower limit. All right, let's see. Remember, when you do antiderivative, you no longer have that dx. That's a property, guys. Some of you guys were still putting that dx in there that I saw that you turned in. Once you do antiderivative, that's it. Because the property that I'm referring to, child, what are you talking about? I'm referring to this. Antiderivative of f prime of x dx is just f of x. And then this is evaluated from a to b, which just means f of b minus f of a. And then some of you were still writing dx somewhere. Like, guys, no, go the way. It's just upper antiderivative, upper minus lower. And then we know that because we already did Riemann sums and width times height and all that good stuff. Okay. All right. So now let's see if we can figure this out. I'm going to distribute this negative. So let's see. Let's see what I have. Well, I guess let's see what this is first. 2/3 times 2 to the 3/2 plus, let's see. The square root of 4 is 2. So I'm doing this. I'm trying to get this to be smaller. The square root of 4 is 2. And 2 to the 3rd is 8. And 8 times 2 is 16. I don't think I did any mistakes, but let me know. 4 squared is 16. 16 divided by 2 is 8. Plus 8. That's this first parenthesis there. Minus, and then I have 2/3 times 2 to the 3/2. Let's see. 2 squared is 4. 4 divided by 2 is 2. And then 2 times 2 is 4. Let me know if you see any mistakes. Do we see any mistakes so far? Are we okay so far? Okay. I see the 8s here zeroing out. Let's see. What else do I see? When I distribute this negative, I see this guy being a negative and this guy being a positive. So I see those canceling out. Do you guys see that? And then I see, what else do I have left? 16 over 3. And then 2, 4, so 2 minus 2, minus 2. Well, this is plus 2, but then I distributed that negative.
Oh, yeah, okay, you did that. All right.
Yeah, I could have, yeah, I know. I did say distribute that negative first, and then, so my bad. Sorry, guys. So let's see what that is. 2 times 3 is 6, so 16 over 3 minus 6 over 3. So what's my final answer? Oh, that was a lot of work. Negative 2 plus 4 is positive 2, and then distribute the negative. I know that I said distribute negative first. My bad, guys. My brain's all over the place sometimes. How do we feel? Okay, so not bad, right? Look what you could have done. So go to the next one, and I did this by design. Notice it's the same question. It says, find the area of the region in example 1 by subtracting the area of the triangular region from the area under the square root curve. So here's what I'm saying. I could have found the area under the square root curve. Here's my square root curve, all of this. And then do you see this triangle region right here? Do you think that would be easier? So I could go, so let me see. I could have gone integral from 0 to 4 of the square root of x dx and subtract, and I'm just gonna write in parentheses area, and I did that in red, so let me color code it in red for you guys. Area of triangle. Do you guys see that? Let's see if this would have saved us a lot of work. So I'm gonna do this part first. Integral from 0 to 4 of square root of x dx is nothing more than x to the 3/2, 2/3 in the front. Let me write it better. 2/3, or you can write it 2x 3/2 all divided by 3. And this evaluated from 0 to 4. Do I have to worry about the 0? No. So I'm gonna go 2/3, 4 to the 3/2. So let's see. Make sure you guys know how to do this without a calculator, guys. So what does that 3/2 means? I can take the square root and then take the cube. If you want to do a cube, you can. 4 to the 3rd power is 64, and then square root of 64 is 8. You'll get the same answer, but I always like to do it whatever is easier. So I think the square root is easier than doing the cube power. So I'm going to do the square root first and then cube. Why can you do that? Why does it not matter what order? Because they're the same. They're equivalent. And in terms of like what comes first. Kind of like PEMDAS, like multiply and divide is the same. Whatever comes first, left to right, is the one that you do. Okay, same thing with that. Did I make sense or did I go too fast? Okay. Here we go. Ready? No, look, check it out, Guerrero. What's the square root of 4? 2. What's 2 raised to the 3rd power? 2 times 2 is 4, 4 to 8. I could have also done this. That 3 means the power and that 2 means the square root. I could have also done 4 to the 3rd power. I don't know if you know that, but 4 times 4 is 16. 16 times 4 is 64. And what's the square root of 64? 8. See, you got the same answer. All right, here we go. 2/3 times 8. I don't know why I did a bracket and parenthesis on the other one. What's 8 times 2? Okay, that's the area. That's what I have in black here. That's what I have in black up here. I'm sorry that I didn't color code that. Now I'm going to do the area of the triangle. So I'm going to come over here. I'm going to write area of triangle equals, let's see, 1/2 base times height. What's the distance from 2 to 4? 2. And then the height, what's my height? 2. 2 times 2 is 4, and 4, half of 4 is 2. So I could have gone 16 over 3 minus 2. OMG, let's turn that 2 into a fraction. 16 over 3 minus 6 over 3. 6 divided by 3 is still 2. What's 16 minus 6? Does that look like it would have been a lot easier than all the work we did on page 1?
Yes.
Yeah. All right, and here we go. Don't worry, this is all by design. Notice that on these, I want you guys to notice these regions, the rectangles, instead of being vertical, they're horizontal. Do you guys see that? So this time, look what is, instead of a dx, that's a dy. That's slice. And your height is in terms of f of y. See, x equals f of y. So now we're going to integrate, instead of integrating with respect to x, we're going to integrate with respect to y. So, and that's all this is. Chav, what's top minus bottom? Top minus bottom, draw a horizontal line, and it's right minus left, because right is a bigger number and left is a smaller number. So right is considered top, the leftmost is considered quote unquote bottom. Right minus left. Cool or not cool? Cool. All right, so let's see if we can do this. Look, find the area of the region, example 1, by integrating with respect to y. Okay, again, I'm doing the same thing, guys. I'm finding this area again. I should have copied it and pasted. I'm sorry. Let me see if I can draw it really fast. I didn't draw a very good job. I apologize. This equation here is y equals the square root of x. The bottom line is, what was it again? I have it over here somewhere. X minus 2. Y equals x minus 2. So do that first. I want to find this area. It's the same region. It's the same. This is the same graph as up here, guys. I just didn't do it. You know what? It doesn't even look like it. Nope. Yeah, you guys got to tell me, guys. Yeah, that's what happens when I don't get any sleep. That's why I have a Red Bull and I drank some more coffee. So I got a Red Bull. And I drank coffee. All right. All right, here we go. Now it's correct. Are we okay? I don't see any error. I think we're good. But notice, what did we say? It says integrate with respect to what? Y. So that means I need dy's. Now dx's, remember, last time we were slicing it like vertical, so those were dx's. So here we go. I'm going to do horizontal slices. So this is considered on top. This is considered on bottom. I need them in terms of the y. So x equals something. So I come over here and I write y equals square root of x. And I'm going to square both sides. Square, square. So that means x equals y squared. That's my equation in terms of x equals y squared. Same thing with the bottom one, guys. So the bottom one is y equals x minus 2. I'm going to move the 2 to the other side. So that means x equals y plus 2. Are we still okay? Now check it out. I need my lower limit. I need this bottom line right here. What is this y value down here? Y equals 0. And I need the top value up here. What is the y value of that point right there? 2. 4 was down here. That was the x value. But I'm integrating with respect to y. Cool or not cool? So here we go. I'm going to write integral. I'm integrating with respect to y. So my lower limit's going to be 0. My upper limit's going to be 2. And then what is on top? That linear line. So what am I going to write? No. Y plus 2. That's on top. Minus what's on bottom? The y squared. and then I close it with a dy. So these are all dy's. If you want to put a giant parenthesis like this, you can. So let's see. Now let's see what's up. Integral 0 to 2 y plus 2 minus y squared dy. I just dropped the parentheses. If you want to put the negative y squared on top and the front, that's fine. All right, come on, guys. Focus, focus, focus. All right, here we go. Antiderivative of y. Y squared over 2. I'm doing it with respect to y, guys. Plus, what's antiderivative of 2? 2y. Minus, what's antiderivative of y squared? And I'm going to evaluate this from 0 to 2. I don't have to worry about 0 because the 0 one, when I plug it into my expression, is always going to be 0. Be careful, though, because if I had an exponent, something to the 0 is a 1. But we don't have that issue right now. So all I got to do is worry about the 2. 2 squared over 2 plus 2 times 2 minus 2 to the third over 3. Let's see what that is. 2 squared is 4 divided by 2 is 2. 2 times 2 is 4. Minus 2 to the third power is 8 over 3. So I have 6 minus 8 over 3. I'm going to multiply. I'm going to get a common denominator. So 6 times 3 with 6, 12, 18 is 18. So 18 over 3 minus 8 over 3. OMG, look at that. Are you shocked that you got the same answer? So now, look, guys. So we've done it all. We've integrated with respect to x. We integrated with respect to x, but then we did a triangle. We subtracted that triangle region out, and we integrated with respect to y. And we got the same answer all 3 times. Yay or nay? All right. Here we go. You need your calculators now, so this is why we have our calculators. It says find the area of the region enclosed by y equals x to the cube. That's this graph right here. That graph is y equals x to the cube. And x equals y squared minus 2. That's this graph right here in sky blue. That one is x equals y squared minus 2. If you want to graph this in the calculator, the top half would have been, let's see, x equals y squared minus 2, move the 2. Y squared equals x plus 2, take a square root. Y equals square root of x plus 2 plus minus. The top half, let me write it in purple here. The top half is y equals square root of x plus 2. The bottom half, this one down here, is y equals a negative square root of x plus 2. Have I confused anyone? I haven't done any calculus. All right. Y'all ready? Mm-hmm. If I did this with respect to x, do you guys want to do it with respect to x and then respect to y? Oh, yeah. If I did this with respect to x, here's my slice. Chavez, I don't understand what you're doing. What do you mean by slice? I want you to see the dx. The dx depends on the top curve and the bottom curve. These two curves. And then once you pass this intersection point, then it depends on this curve and a different curve. Do you guys see that? Yeah. Okay. So, remember, if we have it with respect to x, the top curve is the square root of x plus 2, and the bottom curve is the square root of negative square root of x plus 2. Yay or nay? So, here's what you're going to do. In your calculator, you're going to do this. y1, you're going to type in x cubed. y2, you're going to type in square root of x plus 2. y3, you're going to type in negative square root of x plus 2. So I take my calculator. Y equals, clear. You know what? Let me reset everything. Second, memory, 712. Let me show you. X to the third power is y1. Y2. Square root, was it x plus 2? X plus 2, and then negative square root of x plus 2. And I want my window to look like that window, so let me click negative 3 to 3 and negative 3 to 3. Okay, so window, x min, negative 3 to 3, y min, negative 3 to 3, y max, y3. Y max 3, sorry, lack of sleep. There it is. Do you guys see that region? Negative 3 to 3, negative 3 to 3. X min, X max, negative 3. It looks like this, guys. I'm pretty sure. Is that a -1? Yeah, -1 cubed. Yep, it is. I'm pretty sure this is -1 down here, guys. But make sure of it. So look, second, calculate number 5. Blue curve, yes. Not the red one, the black one, yes. Enter. Yep, -1. Do you guys see that? So I'm going to come back over here. And this AB here, look, they even put letters. Good. That AB, -1, -1. A is -1, B is -1. Are we okay so far? Okay, now I'm going to get the CD. So the CD over there. So it's the blue curve and the red curve. Second, calculate. Practice, guys, practice. Number 5. And then let me see. Let me move out. Which curve is it? The blue curve, yes. And then second curve, the red one, yes. Guess. There it is. It's not a perfect number, so that one you're going to have to store it. 1.2148623 and 1.7930037. I'm going to show you both of them because we're going to need them both. All right. Hook me up with the C value again. C equals 1.21. Yeah. 1.2148 what? 486? I thought it was a 3. What was letter D? Yeah. Okay. Guys, this is super important right here, guys. I need you guys to focus. Do you know how to save these letters, these numbers into C and D? Yes. Look, right now, so I'm going to go slow. Right now, you see how it says the word intersection? Right now, it's stored in a register. That's what the technical term that they call this, an X register of 1.2148 and the Y register of 1.793. At least that's what my professor would always call it. If the terminology has changed, let me know. I want to stay up to date with technology. Okay, ready? I go to my home screen. I type X, and I push enter, and notice that it's that value. I'm going to store it. What letter did we use? C. So I'm going to store it to letter C, so not confuse myself. So there it is, letter C. What about the Y? Chop, how do I get the Y? We're going to need it. We're going to need it eventually. So the Y is way down there. Do you see it in green? You push alpha, Y, and you push enter, and notice that that's that value. So I'm going to store it. How do I store it? Store, and then what do I put? Alpha D. So now every time I use the letter C and the letter D, those are the values. Cool or not cool? All right, so check it out. How do I type it into my calculator? Well, first, never use calculator language on the AP exam or any exam for that matter. Here is the real math. Integral. I'm doing this. I'm adding all this up. So let me go ahead and color code it. Yeah, I'm going to color code it. This is what I'm doing in red all the way to there. And then once I pass that in red, I'm doing this one in blue. All the way to there. Do you guys see that? So I'm going to color code it in red. Here it is. What is the furthest X value? What is my letter A? Oh, no, not letter A. The X value, not letter A. I'm going all the way to A. What is that value right there? -2. So -2, and I'm going all the way to A, which is -1. Now notice, upper minus lower. I hope I don't confuse anyone when I write this. 2 square root of X plus 2 dx. Did I confuse anyone with that? I can see some of you don't want to answer that. Okay. Real quick, don't worry, I'm not going to confuse you. The top line, this purple one, guys, remember I told you that was y equals the square root of x plus 2? Or was it minus 2? No, plus 2. And remember the bottom line is y equals negative square root of x plus 2. Guys, focus, because it is important. So upper minus lower. Look, square root of x plus 2 minus a negative square root of x plus 2. Well, negative times a negative is a positive. Square root of x plus 2 plus square root of x plus 2. Well, this expression and that expression are the same. How many of them do you have? 2. So that's why I have a 2 square root of x plus 2. Do you see that? All right, and now I'm going to add what's in sky blue. So I'm going to color code it. I'm going to put plus. And here we go. I'm going to color code it. Integral From what to what? -1 all the way to what? Not 1.21486. 1.21486. Yeah, the letter C. If you have it saved to C somewhere, or you have C equals whatever, you can put the letter C there. And then I put the top curve again. What is the curve on top? The square root of, perfect, minus, what's the curve on bottom? X. Say it, guys. Don't be. X cubed, yes, X cubed. Look, when you do your slice, this curve's on top, this curve's on bottom, X cubed. I close it with a dx. And there it is. So this will give me my answer. So I take my calculator. So watch. Take the calculator. I'm going to go math. And I'm going to go number 9. -2 to -1. And I'm going to put 2. And I believe I have that stayed in y2, the square root of x plus whatever. y2. And I get out of there. X plus math. And I'll show you another way in case you don't like it. Chubb, I just want to do upper minus lower. -1 all the way to letter C. Alpha C. And then I'm going to do y2. No, y. Let me see. Which one do I have on top? y2 minus y1. Alpha trace y2 minus alpha trace y1. And then I push x on the outside right here. There's my answer. In case you don't like it, I know guys, because I can see some of your faces. If you remember that this curve right here was on y2 and this curve down here was on y3, you can do this and you'll get the same answer. Math 9, -2 to -1. And what did I say? y2 minus y3? Alpha trace y2 minus alpha trace y3 with respect to x. Notice I didn't put a 2 there now. Plus math 9, -1 to alpha c of y2 minus y1. Alpha trace y2 minus alpha trace y1. X. Look at that. Same thing. How do we feel? Nothing crazy, right? Would this have been easier if we would have done it with respect to, look at all this work. Do you think it would have been easier if we would have just integrated with respect to y? It would have. Because look how we had to break up the integrands. See how we have 2 integrands? Okay, so check it out. Look at this, guys. This is super important right here because I want to make sure that you understand. If I would have done it with respect to y, look, here's a cross section. I'm just going to go, anytime you hear me say a cross section, that's like a slice. Like if I have a rectangle right here. Look, it's just the what curve is always on top? The x cube curve is always on top. Do you guys see that? No matter how you slice it. No matter how you slice it, if I slice it, well, okay, no matter how you slice it horizontally, with dy's. All those dy's, my x cube's always on top, and the square root curve is always on the bottom, or the quadratic if you do it with respect to, in terms of x equals y and stuff like that. Cool or not cool? So look what you could have done. You could have done this. You could have said, okay, so let me go ahead and do it here on the side. I could have said this. I could have said integrate with respect to y. If I would have done that, I got to do this first. Y equals x cubed. I got to get x equals in terms of y. X equals the cube root of y, or x equals y to the 1/3. Have I confused anyone? Okay, are we okay so far? And then you already have it in terms, look, they're being nice to me. X equals y squared minus 2 is the other one. That's the square root function, right? The one, the plus minus one. Okay, look at this. Which one's always on top? The y to the 1/3? Which one's always on bottom? The parabola? All right, so look, integral. What's my lower limit? I need the y value, so I need the b. Well, I guess it doesn't matter because they're both the same. -1. But my upper limit, don't say 1.21. I have to use the letter d here, which is the y value. What's my upper limit? 1.79300. Put the letter d in there, and now check it out. I'm going to write y to the 1/3 minus, parenthesis, y squared minus 2, dy. Chop, how do you do it in the calculator, though? I don't know how to integrate with y. Guys, you don't, look, it's just a hack. It doesn't matter what you call that letter. Look, I'm going to come over here. I'm going to go to y equals, and notice, look, I'm just going to go to y4, and I'm going to push x to the 1/3. 1/3. No, look, it's really basic, guys, really basic. It's just a hack. It doesn't matter what I call it. X to the 1/3. And then for the other one, that says y squared minus 2, right? So I come to y5, and I put, look, x squared minus 2. Remember, it's a dummy letter. As long as I have limits. So now, look, I push math, 9. And what did I say? -1 all the way to letter D, and I already have it stored in D. Alpha D. And then look, and I already forgot which one's on top. The y to the 1/3. So what was that? Y4? Alpha trace y4 minus y5. Alpha trace y5. And look at this, guys. I push with respect to x, enter. Look at that. I know, Chop, it's not exact. Look at the end. There's something going on. It's because of the tolerances. The tolerances of the calculator are a little different. But look, the first four digits after the decimal, are they exactly the same? Yes, that's why the AP exam and any exam, well, you know, the first 3 digits after the decimal. Did we get the same thing, guys? It's a little different, but that's because of the tolerances, guys. The calculator has flaws. But look, the first 4 digits are the same. Cool or not cool? Is this making sense? Espinosa, is this making sense? 4.2149. Okay. 4.2149. Yeah, guys, look at that. So hopefully you guys are happy with that one. All right, let's keep going. Don't worry, we're almost done. I think there's the last 2 here. Yep. We're going to go slow, and we're almost done, guys. The shaded region shown below is bounded by the functions -4x squared plus 9. So this is -4x squared plus 9. Y equals -4x squared plus 9. And the line -2x plus 7. Y equals -2x plus 7. And the y-axis and the line x equals 1.5. This line, that dotted line, is x equals 1.5. Find the area of the shaded region using a calculator round to the nearest thousands. Okay. You guys ready? I need to find that intersection. Type that into Y1. Type this one into Y2 of your calculator. So take your calculator. And I'm going to clear everything. Clear, clear, clear. I guess you could have reset it as well. Y1. And what am I going to type in Y1? What am I going to type in Y2? All right, let me see my window here. I'm going from -1 to 5 on the X and -2 to 11. All right, let's see if I can remember that. Window, -1 to 5 and -2 to 11. Push graph. Voila. I don't care about quadrant 2 because they start at 0, I believe. Yep, they start at 0 because I'm bounded by the y-axis, but I do need that intersection. So here we go. Second, calculate, practice, guys, number 5. Enter, enter. There's only 2 curves. Guess? Nah. That little symbol there that you see, that's not a hiccup. That just means where they cross, where the red and blue cross. And it crosses at a perfect 1,5. I guess you could also just look at it. Yeah, that looks like a 1,5. But don't just trust it. Make sure to verify it. So here we go. Integral. Boom. Between 0 and 1, what curve's on top? And notice, look, they give it a name, f of x. So I'm going to say f of x minus what curve's on bottom? G of x. And then close it with a dx plus, bless you square, bless you cube, bless you to the third power. From 1 all the way to, what is that dashed line? 1.5. Now what curve's on top? G of x minus f of x dx. And let's see, equals, and let's see what that is. So I'm going to take my calculator. I'm going to go to the home screen. I'm going to clear this. So here we go. Math 9, 0 to 1. I have f of x and y1. Alpha trace y1 minus alpha trace y2. I push enter. Not yet. Plus math 9, bless you squared, bless you cubed. You got one more. 1 to 1, bless you to the third power. Or bless you to the fourth power. 1 to 1.5. Now I switch the order here. Y2 minus alpha trace y1. And I push enter. There it is. And then 2.583. Bless you squared. 2.583. Bless you third power. Oh, that was a good one. How do we feel? All right, one more, guys. Last one. We're going to do this 2 different ways. We're almost done. Let the shaded region be the area enclosed by y equals square root of x minus 2, the horizontal line y equals 0, and the y-axis. Write an integral in terms of x and also an integral in terms of y that would represent the area of the shaded region. So they want me to do it 2 ways. Don't worry. We're going to go slow. If I go with respect to the x-axis, look, that's a slice. That's a dx. So what line is first? What's on top? The y equals 0 line is first. So if I don't do 0 minus the square root of x minus 2, I'm going to get a negative area because it's below the x-axis. But how do I ensure that it's positive? Like this. And I believe that's 4. 0 to 4. And I write 0 minus square root of x minus 2 close dx. If you don't put the 0 in the front, or if you don't put the negative in the front, you will get a negative number. Are you shocked that it's a negative number? If I do, okay, Chav, what are you talking about? If I do this, don't write this down. Don't write this down. If I do this, this will give you a negative number. This. Are you shocked that it gives you a negative number? No, it's below the x-axis, guys. So how do I ensure that I don't get a negative number? I do that 0 minus. Does that make sense? Okay. I type this because do you have to do it? Oh, let's do it with a calculator. I type that into y1 square root of x minus 2. So take your calculator. And I'm gonna clear y1 and y2. I'm gonna go square root. Don't worry, guys, we're almost done. Square root of x minus 2. And I'm gonna go math number 9, 0 to 4. Was it 0? Yeah. 0 to 4 of 0 minus, I guess you can just put negative, but alpha trace y1. Put the x on it. Enter. 2.66666. It's actually going forever, but there's tolerances that are not being met. 2.666. Cool or not cool? Now they want me to do it with respect to y. So here we go. This is a dy. That's a slice. That's like I would have had a rectangle right here like that. I didn't do my rectangle super awesome. So here we go. That's a dy, guys. I'm just adding them all up. So I need to have this in terms of y. So I take this and I go y equals square root of x minus 2. I move the 2 to the other side. So square root of x equals y plus 2. Square root of x equals y plus 2. Have I confused anyone? No. And then how do I get rid of that square? Sorry, how do I get rid of the square root? Squared. X equals parenthesis y plus 2, close it, squared. Okay, You guys ready? Okay, oh wait. I'm going to integrate. What's my lower limit? -2. What's my upper limit? Good job. Good job, guys. It's like you guys are already pros. What's on top? No. Right minus left. Y plus 2 squared minus, and then what's on bottom? It's this line here, so it's just 0, so you don't even need it. And then with a dy. Here we go. I take the calculator. Math 9, -2 to 0. I'm going to open up a parenthesis. I'm going to type in what I already forgot. What was the equation? Okay, so I'm going to type in x plus 2, and I'm going to close it and square it. And I'm going to put with respect to x. Of course, I'm integrating with respect to y, but this is just a hack, right? I push enter, and look at that. Do you get the same? That's actually a better tolerance because it goes on forever, 2.666. And there it is, guys. Did today's lesson make sense? So do you see how we can integrate with respect to x or with respect to y? All right, we have a delta. Relax. It's not due today. Guys, when am I ever unfair? I knew we were going to take time with the cooking. So we have a delta, and I have the due date for tomorrow. But I would like for you to at least look at it. At least, you don't have to do it all, but at least do 1 or 2 today. All right, we're done.